Welcome to Web Handling. My name is Dave Roysum. In this very short clip, we will review the causes and cures of several defects occurring near the core that have similar mechanics. They include core seam marks, core-to-tail attachment marks, and telegraphing. The last name shows us that some tender webs can transmit the source defect from the core to nearly the outside of the roll in the worst case. I know your time is precious, so let's get started. I had thought that my Dave's Defect series, Web20168A through Z, was very complete when it finished late last year. I went through the web handling sections of the Ultimate Role and Web Defect Troubleshooting Guide to make sure that I didn't miss anything that I wanted to cover. Yes, there are defects in that book that were not covered in Dave's Defects, but that was mostly by design, as many of those defects were pretty obscure. Yet, a senior technical fellow at a client's plant asked me about core seam marks during my on-site Web 101 class. I answered briefly because there's not much to say. Because this defect is seen by webs across a wide variety of industries, it seemed like a good candidate for another one of Dave's defects. This story shows how I enjoy getting questions from around the world and from across industries. They often give me ideas for writing. There are several wound roll defects that are related that occur near the core. One is where the seams in the core marks the layers above. Another is where the cut edge of the tail marks the layers above. Another still is where the attachment of the tail is made to the core, perhaps using tape. If the original insult just marked the layer or two above the core, few people would complain. However, on some tender webs, the original defect can propagate well above the core, perhaps most of the way up into the roll in the worst case. This physics is called telegraphing. This defect should be no surprise to the web handler who knows that the Z direction pressure is guaranteed by the laws of physics to be highest near the core and smaller as you go up into the roll. This defect would be no surprise to the web handler who know that some products are easily marked with Z direction pressure. Marks can also occur on the outside of the roll due to roll handling or due to winding, in which case they may be called drum marks. This turns out to be an exceedingly simple problem to list the causes and cures. The cure begins by winding as absolutely loose as possible by reducing all of the TNTs as much as possible. This also implies that you would have zero taper, because taper requires starting with a higher tension so you can taper. Exactly the wrong thing to do for this defect. This implies no roll structure, because you would be winding loose over loose. You do not want to wind a tight foundation. After you've done everything possible to lower wound roll tightness to the extent possible, the problem becomes solely one of product process design. You can, for example, buy tight-seamed or even seamless cores. You can, for example, cut the tail at an angle, probably an arrow or reverse arrow shape. You could also wind with an interleaf. Of course, all of these options incur additional operational costs. As often the case, the solutions allowed by the mechanics of any particular web handling problem are few, but easily listed. That does not mean that any of the items on that list will be pleasant. Pick the least unpleasant option and pursue it vigorously, rather than hope that someone will invent or discover a physics not yet known that may give a more pleasant list. Thank you so very much for joining me in this defect solving and defect preventing series. If you have a defect you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.